Okay, this is 2.2, general sinusoidal graphs. So a sinusoidal graph is not just a sine graph. It can be tangent, cotangent, any trig function that we're going to be graphing. Okay, I'm going to start graphing this, and then I'll explain what these definitions or these words are after we get this trig function or this sinusoidal graph graphed. Okay, so it's a 4 sine theta. So the first thing you notice is your x is represented by a theta, and you've got 0, 90, 180, 270, and 360. And we're going to do 4 sine theta. So the first thing that I would do is copy down your OIO chart. So let's do that really quick. So sine, cosine, and tangent. And some of you don't like to write down these numbers on the side, but I think it's helpful when you do so. Whoops. So I want to do 4 sine theta. So basically you're taking your sine and you're multiplying times 4. So this is going to be a 0, 4, 0, negative 4, and 0. I've already set up your x-axis and your y, or your theta and your y. So let's go ahead and graph those functions or those ordered pairs. This is going to be a 0, and this is going to be 90 at 4. This is going to be 180 at 0. 270 is negative 4. And 360 is at 0. And you're just going to connect those, and you're going to connect it, try to connect it as best you can in a, not straight lines, okay? Make it curved. So this is a sinusoidal graph, and realistically, this graph does keep going. We're just graphing part of it, okay? This is a periodic, so that means that it keeps going in both directions. And we just graphed these specific points, okay? And it says the amplitude of this graph is. So I'm going to go back up and show you what these definitions are. So it says the amplitude of a sinusoidal is the distance between the sinusoidal axis to a high point or a low point on the graph. So now it's giving you some more words. It says sinusoidal axis. This right here is going to be basically the middle of the graph. Okay? And what I mean by the middle of the graph is you can see that it goes from middle, top, middle, bottom, and back to the middle. So I can see that my sinusoidal axis falls right here on my x-axis. This happens to be my sinusoidal axis. It is not always going to be your x-axis, okay? And it says your amplitude goes from your sinusoidal up and your sinusoidal down. So this right here happens to be my amplitude, or I like to call it the height of the wave. Your amplitude can never be negative. It's always a positive distance because they say it's distance. So in this case, what is your amplitude? It is going to be 4. Okay? Now it says cycle. A cycle is the periodic function, or your sinusoidal function, is a portion of the graph from one point to the graph to which the graph starts repeating itself. So I've gone middle up, middle down, middle. If I kept going, this is going to go back up to the top. So I'm going to start repeating myself if I were to keep going. So this cycle, I'm going to say, is from here to here. This is a cycle. Okay? I've graphed one cycle. The period is basically how long did it take to do this cycle. And so I would say the period of this is 360 degrees. Okay? So the cycle is how long it takes to do one of your pictures, and then the period is the degrees it takes. Okay, I'm going to keep saying those words over and over and hope that you'll start learning those words. Okay, the next one says 3 cosine of x. Remember, so if we're doing x, I'm going to be looking at this right here. It looks like x is going to be radians. So I've got a bunch of pi's here. So if this is my x value, I want to do 3 times cosine x. So cosine x, it looks like, remember, this is 90 degrees, 0, this is 180, if that helps you out. This is 270, and this is 360. So if you want to go back to your OIO chart, I'm looking at cosine of theta, so basically cosine of these numbers, and I want to multiply 3 times that. So this is going to be 3, 0, negative 3, 0, and 3. And I'm going to plot those points. So it looks like I'm starting up at 0, 3, and then this is going to be 0. This is going to be, whoops, can't even read my chart here, negative 3, 0, and then back up at 3. Now, I'm still graphing a sinusoidal function, and I'm still making it a curved line, not straight. Okay, and this looks more like a U. If I were to continue, this would go back. Now remember, I could continue this because it's a periodic function. It just keeps going. This would go back to the middle, and this would continue another U. Okay, so remember, the amplitude is the height of the wave. So here's one, or you could put one here or here. And I'm seeing that because it looks like my sinusoidal axis, which cuts through right at the middle. So I'm going to label this again. Sinusoidal axis that cuts right through the middle. And then from there, I can see my amplitude. And it looks like my amplitude from the sinusoidal axis right here is a distance of 3. And remember, that distance can never be negative, even though it goes below your sinusoidal axis or your x-axis. Okay, so basically from these two, it looks like the graph of any function, whether it be sine or cosine, or you're going to learn some other functions, has an amplitude of, where are we finding the amplitude? It looks like it's right there in front, and it's your A. Now, some other things just to you can tell is if your A is greater than 1, or if your A is less than 1. This kind of goes along with your parabolas. It's the same thing. If it is greater than 1, you're going to have a compression. And if it is less than 1, you're going to have a stretch. And these are going to be vertical. Just like a parabola. And that should be an E. All right, let's look at this one. So we've got, it's kind of set up a little bit different. We're starting with 3 theta, and I want x. So it looks like we're going to have to divide all of these by 3 in order to get my x value, or my theta. So this is going to be 0 and 30 degrees, 60 degrees, 90 degrees, and 120 degrees. But over here, my y value says that I want sine of 3 theta. Okay, so what is sine of 3 theta? So I'm going to go over here and look at what my values would be from my OIO chart again. So it looks like that's going to be 0, 1, 0, negative 1, and 0. Okay, and they did say this was your x value and your y value, so I can plot those. And this is a sine. I don't know if you're noticing anything here. So this is going to be a 0. This is going to be up here at 1. This is a 0 again. This drops down. It's a little bit too far. How about we go right here? And this is at 0. So let's make our curved line. Remember, we're not making any straight lines here. This is curved. Now I'm just graphing one portion of this graph, this sinusoidal. This does keep going, okay? Now, right in the middle of this, some words that I'm going to keep saying over and over. This is your sinusoidal axis, right in the middle of this. And this just happens to be on your x-axis today. I'm just doing some basic ones. From your sinusoidal to the top of the highest wave and to the lowest wave, remember that's your amplitude. So I'm going to go ahead and write that on here as well. Your amplitude of this one looks like it's going to be 1. And from that previous problem, remember your amplitude falls right here in front of your trig function. So there's your 1. Okay. Some other words that I mentioned on that very, very first problem. From your beginning to your very end, this is called a cycle. So however long it takes me to graph without repeating. So if I were to go back over here, I've got an upwards wave there, which starts this over, okay? So that is a cycle. Now, how many degrees did it take me to do that? That is called your period. So how many degrees did it take me to do this? Well, it looks like it took me 120 degrees. And that's actually one of the questions now. The period of this is 120 degrees. Okay, so how did we get that? How did we come up with that? Is there a way we can do the formula? And there is. It looks like we started with 360 and we divided by 3. And is that always going to happen? And there's a critical high, low, or middle point every. Well, there's a critical high, low, and middle. So all these points that I'm plotting, there's one of those every 30 degrees. Okay? What are these points that I keep plotting? Well, these points are called critical points. And are you always going to have critical points? You are. And if you go back, we can see that we've had critical points every single time. On this one, we had critical points here. Okay? So we've had critical points every single time. All right, let's look at the next one. So it looks like this one is in radians. So we've got an x value here. So we're starting with 2x, and I want to go to an x. So I'm going to divide all of these by 2. But we're in radians. So if I'm dividing by 2, you can multiply by a half if that makes it easier. Okay? Multiplying by half or dividing by 2. So this is going to be 0. This is going to be pi over 4. This is going to be pi over 2. This is going to be 3 pi over 4. And how about just pi? Okay, remember this is your x value and this is your y. So how are we going to get cosine of 2x? Looking at our OIO chart, which is kind of saving us this time. 1, 0, negative 1, 0, and 1. Remember, I'm using these values right here because this is 90, 180, 270, and 360 to find these values. Okay, let's plot these. And these are not listed, so I'm going to go ahead and list them. This is your 0 value. This is pi over 4, pi over 2, 3 pi over 4, and pi. Okay, these are my critical points. This is where I'm going to list everything. So when you plot this, this is 1, this is 0, this is negative 1, 0, and 1. And I just plotted my critical points. Make this as curved as you can. And remember, this keeps going. This is a sinusoidal graph, and I've just graphed part of it. All right, let's see where our axis is. It still looks like it's falling on my x-axis, which is fine because I haven't shifted any part of my graph yet. So sinusoidal axis. Okay, and let's look for the height of the wave. Remember, this is a distance. So it looks like the height of your wave right here is your amplitude. And if you wanted to, you could look over here in front of your function. It should be 1. And that is a distance of 1. So your amplitude is 1. Some other words from the beginning. Remember, from the beginning to the end, where it does not repeat is called a cycle. Okay, on the problem before, we found the period. Remember, the period is how many degrees it takes to make your cycle. Well, this one is pi. And there's an actual blank for that one, so let's write that there. The period is pi. Okay, there's also a blank for the critical points. How many times, or what is the degrees or the radians in order to make your critical points? And on this one, it happens to be every pi over 4. The one before was every 30 degrees. Okay, I want to go back before. Look at the one. The period we found was 360 over 3. So I want you to look at this. We took 360 degrees and divided it by 3. Right here, what is represented with 360 in radians? That is 2 pi. 360 is represented by 2 pi. So if we take 2 pi and take the number that is right by your x value and divide it, you get pi. Okay, so we're doing the same thing that we did in the previous problem. Now, how did we get our critical points? In the previous problem, you can take 120 and divide it by 4 in order to get 30 degrees. So what can you do here? You can take your period, pi, and divide that by 4, which gives you every critical point as well. I'm just converting from radians and degrees. So what are you going to do for period here? I've got just a different letter here. So I can take either 360 degrees, if you are in degrees, and divide by that letter B. Or if you're in radians, remember 2 pi represents 360, and divide it by that letter B. So how are we going to get our critical points? You're going to take your period, which we already know, and you're going to divide that by the number 4. Are you always going to use 4? Absolutely. And why I think of the number 4 is because there's 4 quadrants. Your unit circle is divided into 4 basic parts because of your coordinate plane, and that's why you're always going to use the number 4. Okay, now let's start from scratch on a graph with this number right here and this number in front of your axes. Now it does say 2 complete cycles, which we haven't done. So let's try this. The first thing that I always start with is this number right here. This is your amplitude. Okay, the number in front of everything is your amplitude. Okay, now we need to decide what numbers go here and the height and all that kind of mess. So the next thing that I try to figure out is the period. So how do you find the period? Well, you need to decide if you're in radians or degrees, and we're in degrees, so we're going to take 360 and we're going to divide by this number right here because that is your B value. So the period is 72. That means whatever this function looks like, it should end at 72 degrees, and then I'm going to make another cycle and do another 72 degrees. Now, after you know your period, you can do your critical points, and I'm going to call those CPs, critical points. After you know your period, you can take 72 and divide that by 4. Remember, we just figured that out. So there's going to be critical points every 18 degrees. Now, this is way important, 18, because that's where I'm going to start. I'm going to start with 18 degrees, and so there's a critical point every 18 degrees. So 18, 36, 54, 72, 90. Okay, now we just passed 72. 72, you should have realized that you're going to end one of your cycles at 72. Now I'm going to keep going after 90. That's 108, 126, and then 144. 72 and 72 is 144. I should end my second cycle after that. Okay, because I haven't done any shifts up or down or anything, I know my amplitude goes up 6 and down 6. I've got 2 tick marks here, so you can use this tick mark or not. I'm going to say this is 3 and this is 6. This is -3 and this is -6. So cosine looked like that. So I know that my first point at 0 is going to be at the top. Then I'm going to go to the middle and then to the bottom, back to the middle, and back to the top. So I have a full function that ends, that wasn't very curvy, at 72 degrees. That is a full cycle. 72 degrees was the period. So now I'm going to start over. At 72 is the top, middle, bottom, middle, and back to the top. So if I can make this a little more curvy. Okay, and it said to make 2 full cycles. Here is 1 cycle, and then here is the second one. Remember, the period is how many degrees it takes to make it. Okay, let's try another one. So this is sine. In the middle goes up, down, and back and stops in the middle again. Okay, so let's start listing things. The amplitude. Remember, the amplitude is right here in front of sine, and so it's an amplitude of 8. And if you wanted to, you could go ahead and start listing things. So I'm going to go 4, 8, -4, -8. All right, the period. The period you need to start with, well, it's in radians. So I'm going to start with a 360 or 2 pi. And then I'm going to divide by the number that's in front of or right after sine. So that's 1/2. So I'm going to divide by 1/2. And I get radians, or a period, of 4 pi. That means my picture should end at 4 pi, and then another picture should end right after that, doubled, so 8 pi. Okay, now your critical points. You take your period and you divide by 4, which makes this one really easy. Okay, so if this is 0, every one now I'm going to go by pi. So this is pi, this is 2 pi, 3 pi, 4 pi, and that's where one of my pictures should end. 5 pi, 6 pi, 7 pi, and my last one should be 8 pi. Okay, we said sine begins in the middle, then it goes to the top, middle, bottom, and then middle. So making your curved function, there is 1 cycle, okay? Then middle, top, middle, bottom, and then middle. Here is my second cycle, and it ends at 8 pi. Okay, now this just kind of sums everything up. If you have your function and it says +5, of course this is going to be a shift up 5. This is going to be a shift down 3. Now we haven't had any of these, but we're going to get to this. This is going to be, remember, inside the parentheses, this is going to be a shift left of 50 degrees. This is going to be a shift right of 3 pi over 4. So these are going to be vertical shifts. And this right here is going to be horizontal shifts. All right, so what is the difference in if I throw in a negative in front of sine or a negative in front of cosine? Remember, sine, if you were to graph this, I could graph this, and this is a normal sine function. If I were to flip this or put a negative in front of it, the only difference is I would still start at the middle. I would just go down first, then come back up and end. Okay? So I would say that this does a flip over, or a reflection over, the x-axis. Okay? What about cosine? So what does cosine look like? Well, cosine begins at the top, goes middle, down, and back up. And these are my critical points. And if you have a negative, it's going to start at the bottom first, hit my critical points, go up, and then back down, and kind of look like a hill. And so again, this is going to be a reflection or a flip over your x-axis. And you've seen some letters. We've seen this letter right here, A. This is your amplitude, or the height of the wave from your sinusoidal axis. Okay. You've also seen this letter right here. This helps you find the period. And you find your period if you are in degrees by saying 360 over B, or if you're in radians, you say 2 pi over B. The ones you have not seen are D, and I'm pretty sure you might be able to figure that out. Your D is going to shift left and right. Your C is going to shift up and down. All right, we're going to stop for today and finish tomorrow.